This is really a unique opportunity for us to learn from people using climate scenarios. And we've got three very different perspectives represented here with Livio, with Ivan, and with Gianni, representing the European Central Bank, the Bank of Italy, and Deloitte. And this whole scale of different perspectives, a range of different applications represented across that group. Just to add a little bit more to the mix. So I lead our climate-related risk assessment work at EPRI, focused on low carbon transition as well as physical risk. That work is focused on local risk assessment. So it requires us thinking about context that can essentially coexist with those global futures. So I'm really looking forward to learning from the three of you who cover essentially this range of scopes in your comments. For those of us less familiar with climate-related risk work, there are many different types of applications. You're going to hear from three perspectives here. I just highlighted that in terms of very different scopes, very different decision makers, and very different decision objectives from those different types of decision makers. That means different tools, different information needs, and different kinds of outputs. So like I said, here's an opportunity for us to really get into the details with respect to these three applications. So we're going to do a quick round of introductions. Each of them are going to just kind of give you some sense of who they are and their responsibilities. And then we'll loop back around and dive right into learning from each of you. So Livio.
Do you hear me? Yeah. Okay, so good morning, everybody. So I'm Livio STRACCA. I am at the European Central Bank, but more relevant for this event, I am also the chair of the work stream scenario of the standard work stream of the NGFS. So as I was mentioned bilaterally to some of you, I'm rather new to the field of climate, which puts me both at the disadvantage, but also maybe another advantage in terms of looking at things from with a fresh mind, so to speak. So I have a more background as a macroeconomist. So I tend to look at things from that perspective. So if you go to the next slide, please. So, I'm assuming you are all familiar with the NGFS scenarios. So here I just want to give a bit of a snapshot of, so if I were to communicate the new release of the scenario or the scenarios in a single slide, this what. Oh, thank you. So this is what I would probably emphasize. So here we are comparing two of the 7 scenarios. So think of the blue line as the good guy and the red lines as the bad guy. So the net zero. The net zero scenario, so the one where we reach the Paris Agreement, is the blue line, and the red lines are essentially we do nothing about it. So you see obviously that emissions fall a lot in the net zero scenario, but remain essentially stable in the other scenario. So what is interesting also, if you move to the right, so the GDP impact is only visible later. Actually, this is this is more on a side. This is a slightly misleading way to present it because the two in the NGFS scenarios, the way the GDP impact is computed is different in the two scenarios. So actually, if you were comparing the two scenarios the same way, you would have basically the red line above the blue line for a few years. So meaning essentially that there is a trade-off between transition risks and physical risks. So down the road, physical risks take over. So the effect is largely negative. So you may argue is big enough or not big enough, but we always have to think that the GDP is a flow. So here essentially we are saying that by the end of the middle century, the GDP may be like 8-10 percentage points lower, which is like comparable to the effect of COVID. So it would be like having COVID every year. So when people tell me this is a small effect, I always counter that this is GDP being a flow is actually a big effect. So if you look at the oil price, so bottom left is actually it goes up in both scenarios, which is perhaps not so super intuitive, but this is what the scenarios have, and it goes more up in the in the no change scenario, so in the no transition scenario. Okay, so this is driven by higher demand. So essentially, the higher demand for fossil fuels more than compensates the effect on the carbon tax or the lack of carbon tax. And finally, if you look at the bottom right chart, so this is if you can think of it as a proxy for the price of renewables. So this is the biomass price. So you see the opposite, of course. You know, in the transition scenario, this goes up a lot, but it remains stable or goes down in the no transition scenario. So this is just to give you a bit of a kind of first glimpse of what these NGFS scenarios. Of course, there are hundreds of variables. You know, this is just a very selected view. Okay, yeah. So what are the key findings of the latest release? So to reach net zero, now we need, so we are late. So we need a very fast transition. So the transition is becoming more and more disorderly. But it's still possible. So we show that, and we have also added a new scenario, which is called the low demand scenario, which shows that with some behavioral changes, the Paris target is still achievable. And one also important innovation in the scenario, as I mentioned, that the impact. So acute events, climate disasters, and this is reflected in a bigger input. So now to speed up, just to say that we have also released. So one of the criticisms that the scenarios receive in my community of central bank supervisors is that these are too long term. So so they don't. I mean, when we do, for example, stress tests for banks, or when we think about monetary policy issues. So should the central bank, for example, fight? If the climate transition leads to inflation, should the central bank fight that inflation or not? So for these kind of questions, the long-term scenarios are not very useful. So we are developing new short-term scenarios, which essentially are climate-related risks and events happening now, which have an impact in the next 3-5 years. So not at the end of the century, but now. So now I don't have time to go to the individual scenarios, but just so there is a conceptual note online, and we are now selecting a modeling team to model these scenarios. But the short term versus long term is a big question, but perhaps we want to come back to that. And then last slide. There is not a slide. Okay, interesting. I have an additional slide. Okay. Yeah, this one, okay. So just to conclude, I mean, I wanted to emphasize some kind of pros and cons of NGFS scenarios, and probably these apply to climate scenarios in general, I suppose, I presume. So if I have to list the key advantage of our scenarios is first, they combine climate science and economics. I mean, this is also, is the essence of the IAM, of course. But in the NGFS scenarios, we add additional economic modeling. So there is a big macroeconomic model which comes on top of the IAM. So we really push this cooperation between economics and climate science a bit to another level. So we have also frequent updates. So our scenarios are essentially updated annually. So there is a much more frequent update, and we at least aim to make the scenarios user friendly. So now essentially you can go in. There are different websites containing data. You can go and essentially download the data. Hopefully with one click. So that's the user friendliness is important for us. So what are the challenges? So this is these scenarios are built from a set of large models, and it's very hard to see inside these large models. So the interpretation sometimes is difficult. I mean, sometimes I'm surprised at what the scenarios sometimes produce, and I cannot always, at least maybe is my own ignorance, but I cannot explain how the variables behave in the way they behave. There is an iterative process of improvement. So I mentioned the work they've done on physical risk, but it's a gradual work of including new things. So it's not a big bang of improvements. And last point, maybe one criticism of scenarios is that everything is very linear and well behaved. So we don't really model extreme scenarios. Think of tipping points and so on. So and we receive this criticism, but these phenomena are not easy to include in these scenarios. But we're going to try. So we want to explore these possibilities of going to the more extreme. think of a tipping point being reached, and we'll try to explore that. But this is a challenge with this scenario. So I conclude here. Thank you.
Thank you, Livio. We're going to now change to. So we're going to be moving along in terms of scale, moving from the NGFS scenarios to talking specifically about applications within the Bank of Italy from Ivan.
Thanks a lot. Above all, great to be here. Thanks a lot for the invitation. I work at the Bank of Italy as the coordinator of the Climate and Sustainability Hub. So in a sense, supervising and coordinating the various activities of the Bank of Italy on supervision, research, investment strategy, financial education, and also internal operations. I wouldn't define myself as an economist. I'm a practitioner in a sense in the energy and environmental field, and also founder and member of the Italian Observatory on Energy Poverty. So the idea is, we starting from a scenario, but we have a bit of a different approach. Is micro-founded. So instead of using macro models, we are using micro simulation. In particular, we model the behavior of households, starting from household survey data in panel. We have a very nice survey in Italy. It's the household budget survey, going through we have information for the last 25 years on energy expenditure and a bunch of other information. And we use administrative data for firms. What is the idea? The social cost of carbon, the carbon price, let's say, let me be a bit sloppy here, is the starting point for us. So we simulate different possible carbon pricing. We translate this pricing in final energy prices for different fuels mix, for gasoline, for gas oil, for electricity, according to the energy mix in Italy. And so we have a complete picture of the price. Then we estimate a bunch of elasticities, but not for firms and households, but for different kind of firms of households, what we call strata. So we have a kind of 40 elasticity for households, and like 10 elasticity for firms, different sector, different size. This gives us an idea of, you shock the price, how the quantity reacts to the price. Then we simulate the expected expenditure under, if you want, this climate policy that is simply a counterfactual on the realization of a one-off carbon tax with different level of carbon tax according to the ambition of the scenario we are considering. And effects of the scenario on the real economy. Then we have how these things impact the financial world. We have different papers. So one paper, we started with an index of financial vulnerability using a microsimulation model. So that means, for example, that you are financially vulnerable if there is a high share, I don't know, above 30% or 40% of your income devoted to repay your debts. No, you are defined as financially vulnerable. Then we see how these things is connected with the probability of default. That is a measure that is pretty important for us to assess what is going out there in terms of credit risk at the sector level. That is the standard approach we use as central bank as when we are doing stress testing. In another paper, we use individual level for firms, PDs. If you want integrating what we call in-house credit assessment models, these are models, usually the banks should have an internal rating system. It means they have a model where they assess the probability of default of their clients. If they don't have this kind of models, maybe because they're small banks, there is a service that we as a central bank provide to them. We run the model for them in a sense. And we are augmented that model, including the potential shock of a carbon tax. These things, it's simple, and I hope it's not simplistic, and simplicity is a value for us. And if you want, instead of, let's say, going to see what's going to happen in the future, we are observing what's happening across different individuals, across different firms. So we don't have information on the future, but we have a lot of information on the different channel where, you start increasing energy pricing, these things propagate in different ways because different houses are going to react in different ways. Different firms are going to react in different ways. Maybe they are exporting a large chunk of their turnover. Maybe they are not. So this is going to affect them so the strength of the model or this approach is, as I said, it's simple. You can use climate shock, but you can use also this model just to, let's say, for example, modeling the energy shock, the last energy shock. So that's, you can have both those purposes. And as I said, microdata provide you a lot of information. And these are the strengths. You can see there in the slide, you see the red part. Then there are the weaknesses. It's short term, it's a counterfactor. Is the 2022 in Italy with a carbon tax of, I don't know, 800 euro per tons. There's no dynamic. There's no, long-term reaction. There's no adaptation. So that's a limitation. There's not an equilibrium level. There's no reaction with other information that you have. Actually, there's no dynamics is not completely true. You can see in the box the different papers. So we started with this previous paper with my colleagues Luciano Lavecchia in modeling energy demand and doing the carbon tax simulation. Then we integrated these things with the index of financial vulnerability, and there are the different extensions. The last extension, there is a paper with Luciano and other researchers, is exactly the simulation of what happens in terms of financial vulnerability during the energy shock and what could happen in the future according to different scenario price, just to show that, if you can consider this more than a climate stress testing framework, a climate energy stress testing framework. And I think that's all.
Fantastic. Thank you, Gianni. So now a nice stepping off point to Gianni, who's going to take us to another scale altogether.
Thank you and good afternoon. Thanks for this invitation. Gianni Guastella, I'm Associate Professor of Applied Economics at Catholic University here in Milan, in Italy. And my research field is environmental and climate economics. In particular, in the last years, I've been working a lot on microeconometric models, trying to understand the impact of climate risk on business. So basically on the economic and financial value of companies. And 2 years ago, I joined Deloitte as an external consultant with the aim of, say, designing a framework for climate risk assessment at the company level. And now I lead the team of, say, scientists and analysts working on such a framework. Well, concerning the use of climate scenarios, because this business-level climate risk assessment model is obviously, and that's the reason why I'm here, based on long-term scenarios. Concerning these scenarios in the private sector, I think we need to distinguish carefully between the financial and non-financial sector. In the financial sector, basically, the main issue in using scenarios is try to understand the exposure of a financial portfolio to climate risk, and which depends many things depending on what we mean by portfolio, because the experience we have is that when we talk about equities, for instance, the interest is more on say the transition risk. When we talk about mortgages, of course, the interest is more on physical risk. But in the type of risk assessment exercise we do provide, we try always to combine both. And that's the reason why always we end up using the NGFS scenarios, because they are they have this great advantage of combining physical and transition risk in just one place, in addition to the advantages that Livio already outlined. And I think there are also an additional advantage that they have a very clear narrative. So they're very easy to explain and to convey the message behind the scenarios. The approach we use for this kind of climate risk assessment is very similar to the approach that central banks use for climate risk assessment in the climate stress test models. And it's based on this two-part approach. Basically, you have the estimation, so linking business KPI to scenario data. using the historical information. So it's a statistical model basically, and then use the statistical model to make the projections and to shock the projections using the scenario data. And in that way, you can understand what is the impact of climate risk, both physical and transition, on business KPI. In the financial sector, usually the main KPI of interest is, of course, the probability of default, because when you look at the portfolio, this is what you need, the probability of default. The approach is typically top-down. I would like to say is agnostic, so it doesn't really take care of the characteristics of the firm. It's just an application of the scenario, okay? When we talk about the non-financial sector, the story is completely different, okay? In the non-financial sector, I see two kinds of need. The first need is that of disclosing climate risk, because companies, many times, more and more type of companies, but especially large companies, listed companies, they have to disclose their risk. And there are many ways to disclose the risk, but now we are converging in disclosing a climate risk in a way that is consistent with the Task Force on Climate-Related Financial Disclosure recommendation, and also with the International Financial Reporting Standard recommendation. And this implies using scenarios, especially these scenarios below the 2 degrees, okay? And again, that's the reason why we mainly focus on the NGFS scenarios. So basically here, the idea is that you have to disclose, okay? And we use the top-down model similar to the one we used for the non-financial sector. The only difference is now that the model is much more tailored on the need of the firm. So we take into account the geography, the industry, the sites, and many other characteristics of the company to try to provide us a picture that is as precise as possible and as transparent as possible about the risk of the company. And here the KPI is typically the cash flow. You're interested in the future cash flow because then you can discount and you can compute the climate value at risk. You can do a lot of things with this data, and it's very useful using the scenario. And in this case, I see the main difficulty is to really combine physical and transition risk, because the NGFS is very good starting point if you want to look at the aggregate macroeconomic effect of both physical and transition risk. But one of the most important thing at the business level is the impact of extreme climate events in the different scenarios on the company, on the value of the asset, so the damage. That's why I think in this respect, what is still missing is asset level damage functions. Okay, that's what the business sector really needs to improve the kind of reporting to be really compliant with the scenario analysis. The second use we make of these scenarios is for strategy. I think it's also the most important, because take into account that we have detailed data. We are able to access detailed data on the carbon emissions, so type of emissions, how much emissions. We are able to access the data on the decarbonization plan, on the energy use, on the energy transition plan, and so on. And the real advantage on our side from the analysis is that we can integrate this data, this precious information, into the scenario analysis. And in fact, what you see on the screen is basically the comparison of our result of our analysis with and without the decarbonization plan. Basically, what you see in the screen is the result of the two NGFS scenarios. These are the old one, needs to be updated, of course. So the orderly and disorderly that allow to be below the 2 degrees. In the top left panel, this is compared with the current policies, and you see here the variable is the EBITDA. So basically is the cash flow net of the investments that the company need to decarbonize. And you see the cash flow is actually lower. So the difference in the net cash flow between the 2 degrees and the current policies is always negative. In the bottom right part, you see the same picture, but taking into account the firm level decarbonization plan. And you see that at least in the long run term, the difference becomes positive. And I think this is the real important part of the job. So it's, in addition to producing the analysis, what we can do is to try to raise awareness about First, I would say the scenarios, because believe me, so many companies still don't know what these scenarios are, what is behind these scenarios, what the policies that will lead us on the way to Paris, if any, and on the instruments we need and all the problems behind. So they lack knowledge, and what we can do is to raise awareness about this scenario. And the other important thing is that we can raise awareness about the effect of a just and effective decarbonization policy by explaining the companies and business sector that the fast decarbonization will bring advantages in the long run in this case, but in so many happy cases also in the short run. Thank you.
So I told you it wouldn't disappoint. Tremendous set of comments from each of them. We're going to take comments or questions in just a second. So if you have one, please find your way to the front, to the microphone. And while people are thinking of their questions and making their way forward, I'll put one on the table for all of you. So Livio, you identified some challenges at the end of your slide, and that sort of got me thinking about what are the opportunities in this space for addressing not only your challenges, but put the same question to Ivan and Gianni in terms of what you see as critical pain points in the work you've done, and what could we focus on in terms of trying to move forward and address those challenges that you see. So Livio, maybe start with you.
Partly already mentioned. So the biggest challenge we have is probably is on one hand the short-term scenario. So how to bring the discussion more to the present and not to the distant future. I guess that this is an entirely new field. I don't think that anybody is actually doing that. I think of course some tests have some kind of, in some of the tests also Gianni and Ivan were mentioning. So they have these elements. Sometimes there are like things happening in the short term. But comprehensive modeling is also a big opportunity, because it's also we are also freer to model in a way we prefer. So there is more freedom than we have so far in the traditional climate scenarios. Perhaps using smaller models where you understand what's going on. That to me is again, I reason a bit as an economist, so maybe I'm on the wrong track. But having a model where I understand what happens is important to me and to us. This is one thing. The other opportunity, of course, as I was saying before, or the area of development is essentially more non-linear scenarios, or more scenarios where a tipping point is crossed. But that is requires more thinking, and I think we are still a bit far from that. But still, intention is there.
Thank you.
Well, in a sense, I think that these are powerful tools to have people on board. And that's the reason why I underlined before the importance of simplicity. You really need these people believing these things, believing these instruments. For this reason, I wouldn't advise to oversell the results. So I wouldn't say, from my scenario, is the probability of default is going to increase 2 percentage points or 3 percentage points. I mean, there's so much uncertainty down there that I would advise that, these are general trends, these are directions, but we that, are managing the models, and, we look at, standard errors, stochastic components. We know how much uncertainty is out there. We know how much we depend sometimes on data that are far from being perfect. So having people on board, having the right narrative, do not oversell.
Gianni. Yeah, to move forward, I think there are two most important things, as I stressed already, the physical risk part. So the physical risk, because today assessing the asset level, what is the physical risk and the physical damage is really difficult. Of course, we can use different type of data. We have past loss, we have past risk, and so on. But take into consideration that all the story needs to be conveyed to the company. So it's really difficult to talk about the NGFS scenarios and then say, okay, but for physical risk, I need to use other scenarios, because it's difficult for them to just to understand the NGFS. They won't completely understand the switch. So I can estimate damages using the SSP RSP scenario, linking to past data with statistical model damage function. We all know that story, but then it's difficult to convey the message and to explain what you're doing. And the other thing is that we need to understand better the implication of scope 3s in the value chain in our models, because this is actually missing completely, I would say, in the business dialogue. So everyone is thinking about the effects of scope 1 carbon price, electricity prices, and so on. But we all know, we are all aware, at least in this room, of the relevance of scope 3. And this is not the same in the business world. So I think more effort needs to be done on this.
Great. So we have one person. If you have others, if you have questions or comments, please come forward so we can make sure we get you on.
Hi, my name is Mark Roelsma, PBL Netherlands Environment Assessment Agency, also Utrecht University. Well, I first concur with the scope 3 emissions. That's actually really on the high top of our list. So we are going to discuss on it next week. But I have a question for Mr. FAIELLA. So if I understand correctly, your research or your assessment starts off with a carbon price shock. But I was wondering, how realistic is that? Or maybe how should I interpret that kind of assumption starting point? Because I would expect there's a sudden increase in temperature, I don't know, because of positive feedbacks. Governments are not going to suddenly implement a lot of climate policies or increase the carbon tax to a very high level. They probably will start first with quantitative easing again or something, which might be a risk now at high interest rates. And then maybe gradually will increase the carbon tax. So, I mean, I also come from a financial background, so we are really used in these price shocks. But I was wondering to what extent this is realistic in this climate type.
Marcus, thanks. Good question. It's open. Can you hear me? Yeah.
Not super easy to answer. How realistic is that? Let's say that we experience a carbon price shock in 2022 of around 420 euro per ton. So this is the kind of exercise. So the amount of price increase, in particular in gas prices and in power markets, was equivalent to a carbon tax of 420 euro per ton. And that is the idea of the exercise. If you want, it's quite mechanical. So it's true that these things starts, and I don't know how much realistic is that, but at the same time, we know that, you know, more or less everybody is doing climate stress testing using as a scenario. The key variable is always the carbon price. No, that's true that, you know, in the scenario, if you're a longer term scenario, you have technologies, you have other kind of shocks. So that was not an easy decision where to be complex or where to be, you know, as I said before, maybe simplistic in this case, but we prefer to answer. I mean, the point is that the standard questions that maybe a member of a central bank board members can ask you. I mean, what's going to happen if, you know, how realistic is that? How realistic is this price increase is going to change behavior? Another example, everybody was telling during 2022 that no one was going to react to that price. So everybody was making computational, assuming zero elasticity for firms, assuming zero elasticity for houses. That was not the case. You know, there was a reaction. It was, I mean, if I remember well, there was 25% drop in energy use in firms. And industrial production didn't drop. So that was informative, I think. The issue here is that we should know more regarding how firms and individuals use energy. We don't have information on the micro level. That's really a serious issue. But I agree with you that from a political economy point of view, that's not much realistic. It's true. You're right.
So let's take Roberto's question, and then we have an online question, and then we'll come to Nico.
Roberto Schaefer from the Federal University of Rio de Janeiro in Brazil. Thank you very much for your comments about physical risk, transition risk. What about litigation risks? The risk of companies, banks, and even countries being sued and sent to court about, let's say, this lack of effort to mitigate when science has already shown us the importance of mitigation and the possible impacts of climate change?
Thank you.
Anybody want to take that one?
Well, there is a nice NGFS, a couple of NGFS documents on that, on liability risk and where it can come from. It can come both ways. I mean, you can have a liability risk if you don't act. You can have also liability risk if you overreact. That's a thorny issue, I think. And I'm speaking as a central banker, for example. Let's imagine we have as a Eurosystem a climate strategy in the collateral framework. So we are, acting that way. At the same time, our mandate is to have price stability. Let's suppose that we are divesting from fossil fuels. So we are contributing, if you want, in the reduction of the supply of fossil fuels, while the demand is going to be the same. What's going to happen to price? So maybe we can have a litigation because we are not going to abide to our first mandate, this price stability. So it's an important issue. We have to know that. We have to know the potential channels, but it's not easy to answer how to manage liability risk.
Gianni, do you want to offer perspectives from the
non-financial? No, I just want to add that it's also complicated to find the right information in the scenarios, and that becomes difficult to translate into business level assessment. That's the problem. But of course, it's highly relevant.
Yeah, and my only contribution here would be it's very much on the radar of non-financial companies. So just to highlight that it is an issue that people are paying attention to. So we have an online question that's for Livio. So I'll read it first. Are the models discussed by you, Livio, as designed as black boxes with only input and output data available, or is there access to the internal equations? I'm asking to understand the feasibility of integrating these models, and they have a particular application in mind, but integrating with other frameworks.
Yeah, so I would say in theory, all these models are publicly available and are published. So I guess as a matter of theory, I guess it would be feasible, but in practice, the combination of these different models, the fact that they are large size, and also the way they are run and so on, I don't think it's easily replicable for an outsider. But perhaps it's also part of our job to make it more accessible. So perhaps we should also enter our work plan. So I would say, short answer is, in theory, yes, practice, maybe no. So yeah,
a little bit about. All right, so Nico, and before you jump in, others, if you have questions, please come forward. So we're getting near the end of our session, so I want to make sure that if you have a question, that we have a chance to hear it and hear from our panelists. Nico.
Thank you very much. Nico Bauer from Potsdam Institute for Climate Impact Research. Thanks a lot for taking these scenarios and using them. My question is, these institutions, central banks, are very large. There's a lot of information. Can you give us a little impression how this information is internally used? And is there some coordination with other long-term projections on the financial stability, GDP growth, labor markets, and so on? Can you tell us a little bit about this, and also how this maybe relates to other methodologies like macroeconometrics models? Thanks.
So, Livio, do you want to offer some first thoughts?
Yeah. So probably I would say that the two areas where they are mostly used now is financial risk for the financial risk for the financial sector. So climate stress tests. So that's the first area where and I think Ivan and also Gianni were discussing this. Which also takes different forms. So first of all, there are different types of stress tests, and also there are different types of actions that could be taken in their regulation and the supervision of banks. So all these scenarios, I think, are used in one way or another in this discussion. So it's essentially evaluating the risk of banks, stress tests, and supervision and regulation. So that's I think we'll say more traditional use. I mean, more recently, more and more, we also see monetary policy questions. So, what should the central bank do, faced with, the transition? Also, what is the impact of the transition. So for example, is the transition inflationary or not, for example? So will we have inflationary pressure? Will we have higher interest rates stemming from the transition because the transition is inflationary? So more and more also these type of questions will come. And so there are model simulation used internally to show, what is the impact of scenarios of climate policy or lack of climate policy and so on. So these I would say are, but I don't know if Gianni, anyone want to add on this?
Yeah, Ivan or John?
Well, actually, there is a lot of work, but it's a bit piecewise, if you want. I mean, you were asking, if I understand, Nico, if there is some kind of coordination between these two. This is not the case, and I think I'm afraid it's because up to now, we have the great work from NGFS, but the kind of economic output that we have from these scenarios that should be the input of other analysis is very, I would say, simple. No, we have GDP. Probably in the future we're going to have some kind of sectoral detail. But for example, if you want to reasoning on the impact on the labor market in the future, you should have at least the GDP at the sectoral level, no, to have this kind of granularity. So I think that there is a battery of models ready to crunch scenarios in the future when this kind of information is going to be available.
Great. So one more question, I think, before we wrap up.
Thank you for your presentation. And from Utrecht University, I have one topic for the financial side, and is the financial, like payment services or green bonds. Are you planning to part in this model?
Yeah, thanks for the question and for the opportunity to speak about that. Actually, this is not the main use of climate scenarios, I think, but of course, this is, of course, you can use scenario data also in some cases to do this kind of evaluation. For instance, there are some funds that are made just by in carbon capture investments. And of course, if you really want to assess the value of these funds, like also for mergers and acquisitions process, you can use scenario data and use the future of carbon price and future of GDP and so on in order to translate these future values into the current value of the company or of the fund. For natural capital, it's more difficult than ecosystem services because it's a completely different type of say economic assessment and economic valuation, but I've seen that luckily the NGFS is making step forward also in this direction. So hopefully also this will be soon translated into the business sector.
And if I may add, there will be a report of the SRB, so done within the Eurosystem, apart from the task force of natural related risk that published a conceptual framework. There will be out, I think, scenarios for nature-related risk in December, the publication on that. There will be a report on assessing nature-related risk for the Eurosystem that should be published by December. So the things of ecosystem service evaluation and how this thing is related to the role of the financial system, so assessing risk in a sense and providing resources to finance it to improve natural capital is, I would say, high in the agenda of central bankers these days.
So I'm afraid we're getting the hook, I think, from Detlef, unless I can take one more question. Yeah. Okay, so I would encourage you to ask your question and come up and greet the panelists afterwards. So let me end by thanking Livio, Gianni, and Ivan. So if you could please give them a round of applause.